Hello, my name is Jose Pedro Lopez, and I am presenting my EGN 3420 Project 1. Project 1 consists of us having to create a Delta to Wye conversion using either a C script, Python, or MATLAB script. The requirements that were given to us was that we had to be able to ask the user whether it's a Delta or Wye network, and we had to ask the users to input the values they want, which will be, of course, complex numbers as stated down here. And then we had to make the conversion, obviously, and then prompt the script to repeat it so the user can keep do a new conversion after they finish the first one. For the project, I used the C language since I'm more familiar with it, and I started off by using the struct function, which will be which will allow me to use the real and imaginary for every set that I'll be using. And the sets for the struct function will be x, y, and z, which will be for z1, z2, z3, a, b, c for z a, z, b, z, c, and q, r, s will be used to help me do the conversion much easier. And of course, the sum of all the values inputted in by the user. Char network will be used for the scanf function when I'm asked the user whether they want to do a delta to y conversion or a y to delta. And these 9 double variables will be used to help with the division of the final conversion. And in order to repeat the process, I will be using the while function to do this. Once the user decides to either do delta to y or y to delta, if they choose to do to put input D, the script will ask them to enter the x and y value of z1, z2, and z3 right here. The x value will be the real part, and the y value will be the imaginary part of each set. Once the values are inputted, the script will run it through, and it will add all the real values that were entered. So sum.real will enter all the values, and sum imaginary will add up all the imaginary values of the entered inputs. And then for the 3 multiplication for the conversion for ZA, ZB, and ZC, we will use these equations. The top part right here, this will be the real part of the product answer, and the bottom part will be the imaginary part of the product answer. And this will be the same for all 3. And so this is when I use the Q, R, and S to help me make it easier. And this is where the double variables come into play, because I will be using them to help me divide in order to get the final answer. This will be the real part. E, H, and K will be the real part of each quotient, and then F, I, and L will be the imaginary part. G, J, and M will be the denominator of each conversion, which is the sum and the imaginary, the sum of the real and an imaginary combined together. To show the answer, I use the printf function to display the results, and I had the ZA will equal to the 2 decimals of the real answer, which will be E divided by G right here, E divided by G, and 2 decimals also for the imaginary part, which would be F and G right here. Same thing for ZB, ZC, H and J, I and J, K and M, L and M, and that will be the answers for the delta to y conversion. If the user wants to use the y to delta conversion, they will enter W, and it will kind of be the same as it was for delta to y. It will ask for the x and y for ZA, ZB, ZC, which is x, of course, is the real part, and y will be the imaginary part of the set. The multiplication with the exact same equations, but except it will have the real part for the ZA times ZB, ZB times ZC, and ZA times ZC of the entered product. So the top line will be the real part of the product answer, and the bottom part will be the imaginary part of the product answer for all three. Right here, I will add up all the real values of the inputted numbers from the user, and sum the imaginary will be the imaginary part of the sum of them all being added up. Right here, it will be the same way for the division part as for Delta-Wye. E, H, and K will be the real part of the quotient. F, I, and L will be the imaginary part of the quotient. G, J, and M is the denominator of the quotient. I will display the answer the same way as I did for the first part, where I will have Z1 equal to the first part, which is E divided by G. Right here, and F and G will be the imaginary part, and same thing for Z2 and Z3. If the user does not enter D or W, they will be prompted with a sentence that will ask them to please enter it, and they will repeat the process for them to enter it the second time. So this was my this is my script for the project 1. To get an example of how this script will work, I'm going to use the values of the example given in the attachment of this assignment that was given right here. And for the example, they had Z1 equal to 3, Z2 equal to 4, and Z3 equal to -4i. In order to do this, I will put D in order to do the Delta-Wye conversion. So the X value of Z1 will be 3, and the Y value will be 0 since they don't have an I, an imaginary part. And then the X value will be 4, and then the imaginary part will be 0 again because it doesn't have an I. And for the last part, it will be 0 for the X value because it does not have a real part for Z3. And the Y value will be -4 due to it being negative J4 right here. And if I enter it, it will give me the results of 0.04 minus 1.29i, which was the given value for ZA. And for ZB was 1.29 plus J 0.4, which is right here as well. And the same can be done for ZC, which is right here and right here. And if we want to do the reverse, we can just enter W, and we'll put, this is the X value of ZA, Y value of ZA, and same thing for the ZB and ZC. So I'll enter 0.74, negative 1.29, positive 1.29, 0.74, 0.98, and then finally negative 1.72. As you can see, the value of Z1 that was given to us was 3 right here, and it will be 3 plus 0i. And then for V2 we put 4, so it'll be 3.99, which is rounded to 4, plus 0i again. And the last part was negative 4i, which was right here after we round this up. And this is my project for you.